In this demo, we will see how Solid Edge piping design solution helps in creating 3D piping assemblies and generate isometric drawings later with the integrated solution. We believe standard parts are key for piping design. Out of the box, we do provide extensive piping library which consists of different standards DIN, ASME, GIS, GB, PS, and many other standards. With each standard, we do provide pipes and fittings library of different size variations. Even the walls are also included in the library. We can add custom parts or supplier parts to the library database, and this can be made available to all the users across the company. Let us navigate to pump category and select the required part, or we can search based on the different parameters. It is easier to place this pump at the required location. Now, let's create a piping connection between the pump and the heat exchanger by providing a name to the pipeline. For this, we can use 3D sketching tools and select the piping diameter from the pipe specification. However, this pipe diameter can be applied on existing pipe line sketch later, or even pipe diameter can be changed. Here, let's select a 100 diameter pipe from the pipe specification. These sketch lines are associative to end connections and geometry can be constrained as required. The solution also shows different alternative options based on the selection, and we can choose a right option before completing the sketch. Similarly, we can add a branch line and connect to a vessel and define the constraint as required. We can provide geometrical and dimensional constraints. Based on the branch point definition, the piping assembly will get updated later. As we come out of the environment based on the pipe diameter and fittings information from the pipe spec, the piping assembly gets created. This keeps away the guesswork out and piping assembly is created with fittings as per the standards registered in the pipe specification. A closer look on this piping, we can see fittings like flanges, T-fittings, elbows, gaskets, etc. placed on the right location on the piping. Let's delete a flange at one end of the pipe and place a wall at the same location. We can place a wall from the pipe specification on the selected pipe segment, and it shows the list of matching walls based on the pipe diameter. We can preview the wall before placing the it wall on the piping assembly. It is easier to place the wall on the pipe segment by defining the assembly constraint. We can update the piping to accommodate new wall, and it also adds the flanges and gaskets at the wall ends based on the pipe specification information. If necessary, we can remove the unwanted pipe segments from the piping assembly. Based on the selected geometry and constraints, the pipe segment will be deleted and the pipeline will be updated. Out of the box, we have design rule checks which can be run on piping assemblies to validate the piping assembly. We provide diameter check, flow direction check, and assembly size check to pipeline size with all the connected components. Let's validate the assembly against the assembly size check. As we can see here, there are components that is one of the pump end and connected fittings that have a different size diameter. We can fix this issue by splitting the pipe and changing the pipe diameter of one side of the pipe segment. Once we specify the reduction in the pipe size from the pipe specification, the right elbow gets placed and the pipe and corresponding fittings gets updated. In this case, we are reducing the pipe from 100 to 80 diameter. Even it is possible to place the reducers directly on a pipe segment. We can preview the piping components information in the piping window pane. The components can contain the information which is being driven from the pipe specification or from the PNID application. The components like casket can contain additional component information which needs to be part of the final bill of material, that is the number of bolts, nuts, washers which are required to be assembled to complete the assembly. The components also contain the pipe specification information, material, pressure, and diameter information, which later can be used for isometric drawing generation. This is very useful information for the piping designer before isometric drawings are generated. Now, let's generate isometric drawings for the piping assembly. Solid edge isometric is integrated solution. It can read the piping assemblies with all the information and generate the isometric drawings. You can browse any piping assembly or it selects the active assembly for isometric drawing generation. Here we can view all the piping information of components and fittings. Information from pipe specification, part specific information, PNID information, additional virtual component information, and PCF information can be viewed in the dialog. It is possible to map CAD properties to these isometric PCF properties and generate property values based on the formulas or script. We can cross highlight pipeline paths and components on the assembly display. Options are provided where we can define the isometric output styles. These styles can be configured according to your company's standards. Even different output types like DWG, DXF, PCF, solid edge draft file, etc., can be selected before generating the isometric drawings. Let's select the cut list and weld list type outputs and continue creating drawings. These generated outputs can be opened in Solid Edge and viewed. Here is an isometric drawing with all the information including the cut list table to fabricate the piping assembly. Similarly, here is an isometric drawing which includes the weld list table with all the other information. With solid edge piping design, you can create complex piping assemblies with ease, and with integrated isometric application, it helps in rapid generation of drawings from the piping assemblies.